Okay, we're here. All right, now let's look at the human eyeball for a second. Okay, here's the anatomy. I don't. Most of you all know more, probably forgotten more anatomy than I'll ever know. So I'm way out of my element here, especially talking to you guys. So anyway, but all right. So notice these ciliary muscles here. All right. For those of you who are wearing glasses now because you're young and you're nearsighted, these were too strong, and what they were doing was they were smooshing your lens, and so that the image that's showing up on your retina back here is too was showing up like here, and so everything was blurry. All right, and those of you who are like me, who are farsighted, I can see far away pretty well. Not so well anymore. Now I need bifocals. I need a little help on both ends. My image on my retina is showing up back here. And so what we're getting is when we look at something, we are actually, here's what's happening. We're actually getting a real image formed on our retina back here, on the retina back here, and it's inverted and shrunk, of course. When I'm looking across the room at my guitar hanging. That's not hanging, but it's in its stand right over there, and it's pretty tall. But actually, if I hold my fingers, it's about 3 inches tall. But on my retina, it's going to be really, really small. It's going to be upside down and real. And here's what happens. So when I look at a distant object, my eye's all nice and relaxed, and I get this image right here. Okay? Now look what happens to the focal length when I look close, when I'm trying to read something. All right? It's tensed. This is why you get tired when you read. Okay? You get tired when you read because your eye tenses up. All right? So your eye gets all tense and it's not relaxed. That's why you can go to the movies and sit there and sit back, or you can binge watch a Netflix show or an Amazon Prime show or Hulu, whatever it is, and watch all 8 seasons of Breaking Bad or whatever, in 3 days or something. Because when you're watching, your eye is relaxed. Okay. So if you've got nearsightedness, like a lot of you had, you need a diverging lens, because here's what was happening was the image, when you're trying to read the things, they weren't showing up on your optic nerve. Okay, so we add a pair of glasses to the diverging lens, and what it does is the far point is out at infinity. Okay, the far point's out at infinity, and it brings it in, and there you go. Right, and this one's the far point's out at, and it brings, and you've got a far point that's not at infinity. My far point used to be at infinity, but it's not anymore. So what does that look like? Let's take a look at what that looks like. So let's take a peek at the farsightedness first. Okay. Well, yeah, I've already done that. So what am I after? I'm after my ladybug. Here we go. So farsightedness. So nearsightedness. So when you can't see far away. Nearsighted. Okay. Myopic. So here you go. You've got this. You've got your far point. Your far point is now is not equal, does not equal infinity. For a regular 20/20 vision person, the far point is at infinity. Okay, far point equals infinity for normal eye, for whatever that means. Okay, for normal eye. So what does that mean? We look at the focal length. Then when for the lens of the eye, we've got one of the focal length is equal to the distance of the object, 1 over infinity, plus the distance of the image. May not be, the distance of the image is supposed to be at 2 centimeters, which is about how big the length of your eyeball is. Now let's say is at well, let's put it at 2 centimeters. This is for a healthy eye, at 2 centimeters. Okay. All right. Then the focal length. 1 over f. What is this? This is equal to 1 over 2.0 centimeters. Okay, and so F is equal to 2 centimeters. Let's put F into meters. That's 0.02 meters. And so the power of a healthy eye, of a normal eye looking far away, the power is equal to 1 over 0.02. I think it's around 50, isn't it? Yeah. The power of a healthy eyeball is 50 diopters. Okay. Now then, if I've got to add a number here, if I have something other than 0 here for the actual distance of the object, but actually what we're doing is we're tricking your eye, and this object is going to be negative, right? So this object's going to be negative. So I got to bring it, so to get the focal length, it's going to be, your power is less than 50. It's less than 50. So I'm going to need to add diopters to it. So therefore we have negative diopters. I'm going to make the focal length, I'm going to add a negative here so that it takes care of the negative there. Okay, that's why diopters are negative. Diopters are negative for nearsightedness. I'm going to stop there. Now we can go on to the next one. So let's look at the problem that they have for us then. If what I just said made any sense whatsoever. So let's look at the problem that they did. Okay, a nearsighted person has a far point located only 521 centimeters from the eye. Okay, so that's 5.2 meters. That's not too bad. That's not too bad. That's 5 meters away. They can make, things are pretty clear up to 5 meters away. That's not bad. From the eye. Assuming the eyeglasses are to be worn 2 centimeters in front of the eye, find the focal length needed for the diverging lens of the glasses so the person can see distant objects. All right. So here's what we're going to do. So we're going to subtract 2 centimeters here. And because we're going to use this right here, and then now we're going to subtract, now the distance of the object, which we're bringing in closer to the eye, is not at 521. We're bringing the near point into 519. Okay? So therefore, everything will get shifted back. Because see, this guy's here. I need to shift this back, so I'm going to bring him forward so this shifts back. So it falls on my object nerve and I can read it. Sounds like a lot of gobbledygook, doesn't it? But here's how they did it. They're treating it like the far point should be out at infinity, so the focal length is negative 519. Okay. Farsightedness. So what are the diopters here? Let's look at the diopters here real quick, and then we'll go to nearsightedness. So for the farsighted person, nearsighted. So for the nearsighted person, we had this. We went, all right, so the distance of the image that we're going to bring, since their far point from their eyeball was equal to 521 centimeters, we're going to turn this far point into the distance of an image, which is negative, because 2 centimeters for the glasses. You always subtract 2 centimeters for the glasses, all right, from the eyeball. Don't worry, on an exam, when we look at these on Tuesday when we meet again and we kind of go over for the exam, I'll make sure that we use contact lenses so you don't have to worry about this little piece here. So here's what we do. All right, so now we need 1 over f is equal to 1 over infinity, which is where the object is, which is the distance of the object, plus 1 over negative 519, all right? So let's change this to meters. So I've got 1 over f is equal to negative 1 or 0.519, which is my power. And so let's figure out what the diopters are in this. So it's 1 divided by negative 0.519. Negative 1.9. That's not a really strong prescription. Negative 1.93 diopters. Okay? Now, we'll do farsightedness next. Sound like Bugs Bunny. Next. All right, here we go. Oh, shoot. I always forget how